In the last lesson, we talked about parallel lines, which are just lines that never cross. And today we're going to talk about a different type of line, perpendicular lines. And we're going to see how they're both super important in buildings and in any type of engineering thing that we do, right? So the parallel lines, you can see all the floors are parallel. And you can just think about how important that is, right? If one of those floors went at some weird angle like this, right, it would crash into the other floors. That doesn't work. They have to be parallel. They can't cross. It's the only way it really works, right? The other type of line you can see are these vertical lines, and those are perpendicular to the parallel lines. And you can imagine how important that is that they go straight up and down. If those went at a weird angle too, you'd end up having a building that was going to collapse. So perpendicular lines crossed at a 90-degree angle. We also call that a right angle. So this right here is a 90-degree or right angle, 90-degree or right angle, 90-degree or right angle, 90-degree or right angle. And that's how we test that a wall is perpendicular or going straight up and down compared to the floor. We measure the angle, and we'll see that in a second in a little more detail. But here you can see what happens when you don't have perpendicular lines, right? Perpendicular would be something like that, and to the ground, a right angle right there. And you can see that building's tilting. Eventually it's going to fall over unless they figure out some way to support it. But that's why it's so important to have perpendicular lines and parallel lines when you're building. Now, perpendicular lines are everywhere. You can see it in the cross. You can see it in a road intersection. In your textbook, the way they show it are these little boxes. They say that these are perpendicular, that's perpendicular. And this is a common symbol for perpendicular too, this upside down T. So you'll see that a lot. In a rectangle, all four angles are right angle or 90-degree angles, and that's how they mark it. And again, down here, this is what you'll see with the little box. That means 90 degrees. Now, what's 90 degrees? Well, if a circle's 360, and you went all the way halfway around, that's 180. And then half of that right there is 90. And I think this actually comes in right there. That's 90 degrees, right? And you can see that right there is our right angle. It's going straight up and down compared to the bottom of the screen. Now, when we work, how do we make sure everything's 90-degree angles? Well, there's guys using a little tool we call a speed square. But again, all that's making sure is that he's cutting at a 90-degree angle, and that's going to make sure that everything is flush, meaning everything that's supposed to be vertical is straight up and down. Everything's supposed to be flat, like different floors are parallel to each other, and they're not going to cross. Now, parallel lines, the way that we knew they were parallel in math is we tested their slope, and the slopes were the same. Perpendicular lines we're also going to test using their slopes, but their slopes are not the same. Their slopes are negative reciprocals. Negative means we change the sign, meaning if it's plus, it's negative. If it's negative, we switch to positive, right? And reciprocals, think of this as we flip the fraction. And you'll see what that means in a second, okay? But negative, change the sign. Reciprocals, flip the fraction. So the red line. The red line's slope is 2, and I could rewrite that, right, as 2 over 1 if I wanted. The blue line, its slope is 2, and I can rewrite that as 2 over 1. So you can see right away these are parallel lines because they have the same slope. But this green line, notice it's negative 1 over half. So we took 2 over 1 and we flipped it, right? We flipped both to get 1 half. But we also took a positive and then made it a negative. So that's what we mean by a negative, change the sign, and reciprocal, flip the fraction, okay? And you can see over here, sure enough, the red and the blue lines are parallel. They're never going to cross. They have the same slope. But that green line crosses both of them at a 90-degree or right angle. And the way we can see that in the equation is that this slope is the negative reciprocal of these slopes, right? We flipped the fraction and changed the sign. So now we have a question, same idea, right? Write the equation of a line that goes through this point. They gave us a point on the line and is perpendicular to this line. Okay, so I'm always going to start with my generic equation, y equals mx plus b. And the only thing I need to figure out is the slope and the y-intercept. Now, they didn't give me any of them specifically, so I just have to think, what do I know? Well, I know that my line is perpendicular to this line. And I know the slope of this line is 4, or 4 over 1. So the slope of any line perpendicular to that, right, is going to be 1 over 4. I got to flip it, and I got to change the sign. That's positive, so mine's going to be negative. Okay, so I'm going to take that, and I'm going to plug it in. So I know my slope has to be negative 1 over 4. So I'm just going to pop that in. Y equals negative 1 over 4x. But I still don't know b. okay? If they told me B, if they said the y-intercept is this, I could just plug it in. But they didn't, but they did give me something else. They gave me a point. And I know that every point gives me an x and a y coordinate. And I can plug those into my equation. So I could take this x, and I'll just change the color here so we're not confusing these lines. I can just take this x, -4, and I can plug it in there. And I can take the y is -2, and I can plug it in there. And when I plug that in, the only thing left will be b, so I can solve for b. So the y is -2. My slope is -1/4. X is -4, and plus b. So again, the only variable left now is b, so we can solve for it. So I have -2. So here I have a negative times a negative. So I'm going to end up with a positive. And the divide by 4, multiply by 4, that's going to cancel out, right? So we're going to be left with just 1. And if you are uncertain about that, just check that out separately or check it out on a calculator or on Desmos, wherever. Just multiply -1/4 times -4 and you'll get +1. All right, so that's just 1 plus b. If I subtract the 1 from both sides, I can get b by itself. -3 equals b. And so I have my y-intercept now. And so now all I have to do is just go back and plug that in and I'll have my equation. Y equals -1/4 plus b, but it's a negative, so I'm going to write -3. Oh, and I don't forget my x. And that's the equation of your line. So notice the slope was -1/4, which is the negative reciprocal of 4. Which two lines are perpendicular? So again, all we're looking at is the slope. So again, I do not care. Look, the y-intercept here is -1. I'm just going to block it out. Y-intercept here is 2. I'm just going to block it out. I don't even care. All that matters is the slope. If the slopes are negative reciprocals, they're perpendicular. So the first line, the slope is 3. I can rewrite that as a fraction if I want, 3/1. The next one is 1/3. And you might think, oh yeah, those are perpendicular because I flipped it. But remember, the sign also has to be different. So the first two are not perpendicular. The next one, though, -1/3. So think about that. I took the 3/1, flipped it, and changed the sign from positive to negative. So these two are perpendicular. And I can write this, I can write that sign, right? That symbol means perpendicular. Okay, but not the red one. So let's see this on the graph. The green and the blue we're saying are perpendicular, and sure enough, they meet at that right angle. And the red and the green, that is not a 90-degree angle. Imagine if that was a building, right? And this was your floor, you'd want the walls to go up like that, not at the angle that green line's going up on. So you can see it in the picture, you can see it in the slopes in the equation, and that's all you need. Every problem starts with that idea. Are they perpendicular? Check the slopes. If the slopes are negative reciprocals, meaning they have different signs and the fractions are flipped, they're perpendicular, otherwise they're not.